Okay, so this should be a relatively quick video about even and odd functions. If a function is even, then that means that it is symmetric with respect to the y-axis. To determine if something is symmetric with respect to the y-axis, then we are going to keep the y the same and negate x. If a function is an odd function, then it is symmetric with respect to the origin. To determine if something is symmetric with respect to the origin, then that means that we are going to negate both my x and my y. So this is what we're going to do very quickly for this one. Okay, so for starters, when I have something in function notation, I'm going to go ahead and replace that with y so that it's easier for me to go ahead and determine my symmetry. So to determine if this is symmetric with respect to the y-axis, I'm going to negate x. So y is equal to a negative x cubed minus a negative x. Notice every time I put in a negative, I'm going to go ahead and make sure that I use parentheses. So this gives me y is equal to a negative x cubed plus x. Is this what I started with? No. So at the origin, negative y is equal to a negative x cubed minus a negative x. So I get negative y is equal to negative x cubed plus x. Again, I don't like to leave my y's negative. So I get y is equal to x cubed minus x. Is this what I started with? Yes. So that means that this is an odd function. It is rarely possible for a function to be both even and odd, but it is possible for them to be neither. So, again, I'm going to go ahead and change this to y is equal to negative x squared plus 6. I'm going to determine if it is symmetric with, if this is even, so if it's symmetric with respect to the y-axis, that means I'm going to leave y the same. I'm going to negate x. So I have y is equal to negative, remember x squared. Negative x squared is a positive x squared plus 6. Is this what I started with? Yes, it is. So it is symmetric with respect to the y-axis, so it is even. And I'm not even going to check the odd. Let's look at another problem. Okay, again, I'm going to change f of x to y. I'm going to negate my x's. Every time I'm going to negate an x, I'm going to make sure I put it in parentheses. Anytime I negate anything or I have a negative, I tend to end up using parentheses to keep me straight. So this gives me a negative x cubed minus x squared plus 2x. Is this what I started with? No, so this is not even. So let's check the odd. So that means I'm negating both. So I end up with this bottom part here because that's what happens when I negated the x. So I need to get rid of my negative 1. So I get y is equal to x cubed plus x squared minus 2x. Is this what I started with? No, so this is neither even nor odd. Okay, so a quick little recap. It is possible to be neither even nor odd. If a function is even, it is symmetric with respect to the y-axis, so we keep the y the same and we negate x. If it is odd, it is symmetric with respect to the origin, so we negate both x and y. And then we just determine which one it is. There were a few more examples. I did 3. I did 1 that was even, 1 that was odd, 1 that was none. If you have any questions, just let me know.